Maybe you've done this a little bit in your background, maybe you haven't. If you're going to go to college algebra, complex numbers are going to show up in there, and you want to know have these concepts down for further things you're going to learn. If you go to trig, complex numbers are in there. If you go to calculus, you'll see some complex numbers in there. The idea behind a complex number, and this goes back several hundred years. If you were to go back 2,000 years, people kind of had the idea of a square root 2,000 years ago. But back in those days, and we even kind of knew what negative numbers were, people just kind of thought, well, this is nonsense. Okay, we've already talked about that. So if you're doing a square root of -4, the thought process is there anything I can multiply by itself to give me -4? No. Okay, there isn't really any real number that gives that. So does that have an answer? It really has no real number solution. And at this point in time in the class, we've only talked about real numbers. Real numbers are decimals, fractions, negatives, positives, whole numbers, everything. A complex number is a totally different idea. So you cannot think of a number times itself that would give you a negative number. Okay, does that make sense to everybody? If you multiply two numbers out, it's mathematically impossible to multiply like two negatives. You would never get a negative, right? If you multiplied two positives, you would never get you'd never get a negative, okay, like that, okay? So it's impossible. Does that make sense to everybody? Okay, so here's what the idea was. So back in the days, this goes back up to about the 1500s from Rene Descartes, and he kind of thought, well, let's pretend like there's an answer to that. Let's pretend, which is weird. Mathematicians do that all the time. So if you had an equation like this, if you had something squared plus 1 equals 0, at this stage, you could not find an answer to that problem. Because what happens if you square any number? What do you get? What kind of number do you get? You get positive, right? If you add a positive number to 1, are you ever going to get 0? No. So anytime you square something, you're never going to get something that you would add to 1 to get 0. Does that make sense? Okay? So it's impossible. So back in those days, people just said, nonsense. That's just a ridiculous question. Don't even ask me. But then Descartes came up and said, let's pretend like it exists. Now, this is what's weird about math. He imagined a solution to be there, and we ended up calling this an imaginary number. And it shows up in science all the time. Okay? A lot of things we know about electronics and physics, we wouldn't have any of that knowledge if it weren't for complex numbers. So he just kind of imagined it existed. Then we started finding all this math out there that was built on that. So that's kind of interesting to me. So what you want to do, the key thing you want to have is you want to understand that we call the letter I the square root of -1. We imagine that such a number exists. And that's what I is. We also do this. You also, by definition, want to know that I squared is -1. Where that comes from, by the way, is, and this is kind of what we were talking about today, the idea is if you square both sides of this equation, you're going to get I squared and the radical is going to go away, right? We did that today. When you squared a square root, the radical went away. So the whole imaginary number system is built on those two ideas. Okay, that's the idea, okay? So we're going to kind of learn how to do that then, okay? I don't know if you guys get this joke or not, but I don't know if I get it. Oh, that's an imaginary number. That's an imaginary number right there. Okay, so I is an imaginary number, and then pi is a real number. So this guy, I is saying to pi, hey, get real, and that's saying, hey, you be rational, ha, ha, ha. Okay? All right, I see that like a lot of times on the internet and stuff, and Facebook and stuff. Okay, now I love this joke. This one's awesome, okay? I've never had a student ask this. This is a great excuse to give your math teacher. It says, why are you turning in a blank sheet of paper? Because all my answers have imaginary numbers. I like that one, okay? That's a great excuse, okay? But actually an imaginary number could be written on a piece of paper, so it's not valid. Okay, so what I'm going to do here is I'm just going to teach you how you write a square root of a negative number. So what you do on this is you'll learn to start doing this more in your head, but what we do is we break it down into -1 times the square root of 9. Because you know -1 times 9 is -9, right? And then when you see this, that's what I is. So that thing becomes I, and you know the square root of 9 is 3, so we just write the answer as 3i. So from now on, if I want you to know, if I ask what's the square root of -9, Okay, you don't have to say it has no real solution. You can say it's 3i. That's why, okay? Now, let me show you this, okay? The y part's real important on this. You guys have already learned this. Like if you had the square root of 25, you know that's 5. How do you prove to yourself that the square root of 25 is 5? You do 5 times 5 is 25. How do you prove to yourself that the square root of negative 9 is 3i? Well, you do this, and write this down because I want you to know this. I want you to know the y part behind this. If you did 3i times 3i, you get 9i squared. Okay, you know what I told you on the previous page I squared was? Negative 1, so it is negative 9. Okay, if you look on the previous page, I said, by definition, whenever you see I squared, you're going to get a negative 1. So the mathematics works out on that. Okay, if you take a square root of a negative number in the imaginary world, it'll work out beautifully. Okay? Okay, it's kind of weird. It's kind of abstract, but it's not difficult. Okay? So the answer is 3i. Okay? I'll drill you on this in a minute and you'll have this down easy. So the next problem, you start the same way. You say square root of negative 1 times 256. Okay, what is the square root of negative 1? I. You could take your calculator if you wanted to and do the square root of 256. I'm pretty sure that's 16. Somebody can check me on that if you want to.
Yeah, 16.
So that's 16i. The answer to that problem is 16i. Okay? All right? That's how that goes. All right, so before I go to the next problem, let me just teach you how to do some of this in your head because you want to be fast on this. You want to understand this, but you also want to be able to do this quickly in your head. What would be the square root of negative 4? 2i, right? Square root of 4 is 2, but it's imaginary. How about the square root of negative 16? What's that? 4i. Square root of negative 81? 9i. See what I mean? You already know that. Okay, it's just that I piece comes in now. Okay, the next problem, what we're going to do is we're going to break this up so we have negative 1 times the square root of 162 like that. Okay, again, that's an I. Now we need to think about what we're going to do with 162. Now this is what we've been working on in recent classes, is we need to simplify that 162. Generally, what most of you are doing is doing a factor tree. You can do that. So I'm going to start this way. That divides by 2 because it's an even number. Then it's 81. Okay? Now when you do a factor tree, if you see that you have a perfect square, you don't have to go any further. Do you know what the square root of 81 is? Yeah, so you could break it up into 9 times 9, but you don't have to. Okay? You can bypass this and just write this like this. This is going to be I, and then that's going to be 2 times square root of 81. Okay, otherwise, if you broke the 81 down, eventually you would end up with 3 to the 4th, when you can do it that way too if you want to. So here's what you have. The square root of 81 is 9. That's no longer in a radical. You have the I, but the radical 2 is left over, so that's the final answer of the problem like that. So what you're applying in there is something you already know how to do, is the breaking up the radical piece with the factor tree. Okay, does that make sense to everybody? Everything that we're applying here is part of what we've been doing in this chapter. Okay? Okay, next problem. Okay, let's start this off by saying square root of negative 1 times square root of 220. Okay? So that's really going to be I times root 220. And you can bypass that first step. I like you to do that because I like you to know where that comes from. So what I'm going to do now is I'm going to do a factor tree for the 220. Okay? All right, well, let's see. I'm going to start by doing 22 times 10. Just whatever you find, okay? Now, what I'm going to do from here is that's going to be 2 times 11. Those are prime numbers. Remember, we're looking for 2 of something, at least 2 of something. That's 2 times 5. So we did find 2 2's, okay? So the way I've taught you how to do this now is if you go back to this problem, you're going to have I. Then what you're going to do is put this together. So I've got 2 to the second, like that, times 5. I just have 1 5, so I'm going to write that as a first power, and 11 to the first like that. Okay? Now, we've been doing this for a while now, so tell me what comes out of that radical. 2 to the second. Okay? Why do the 5 and 11 stay under there? Exponent's too small. Okay? 1's less than 2. So when you take the square root of 2 to the second, what do you get? Itself, 2. Okay? So like we've been doing, this one is going to be the one that comes out. Okay, so what you're going to have is you're going to have the I. The square root of 2 squared is 2, so put 2i. Don't put I2, put 2i. Okay, then what's left is 5 times 11. Since those can't come out of the radical, you want to leave that alone. So that you would have 2i radical 55 like that. The only thing that's different about this is the I part, not this breaking up the radicals. That's something we've been working on a little bit here recently. Okay? Okay, so I'm going to have you do the next 5 problems. Let's go ahead and take a little bit of time to do. Okay, so nobody really, I didn't see much trouble, certainly on the first 2. And you can do this one in your head, okay? You know that the square root of 4 is 2, but you also know it's an imaginary number. So if you can do it in your head, you can do that. The next one's the same way. If you're really doing this, now you can learn to do this like this. A lot of times I show students to do this. You know it's imaginary, so you can just kind of, in a sense, pull that out and think of that as I root 100. You can start the step that way if you want to. You can always start it that way. Well, that's I times 10, so that means the answer is 10i. Okay, so I think everybody got the first 2 okay. All right, this one you can start the same way. If you want to start doing it this way, you can. That's just I times square root of 400. Okay, what's the square root of 400?
20.
Not everybody did that one right. Okay, remember, if you're not sure, just get your calculator out and try that out. I know that 2 times 2 is 4. I know the square root of 4 is 2, so that's going to be I times 20, or just 20i. So that's what you should have got there. Okay. Some of you are having a little trouble with the next one, so what I'm going to do on this one is just kind of break it up like this. This is the way that most of you are doing it, just starting this way. That's the way I taught you, okay? So that's going to give I radical 160. And I'm going to show you 2 ways to work out that square root of 160. You take your pick. I don't care which way. Okay, let's start by doing a factor tree. Let's go that way. So that you could start as 16 times 10, and I'm going to take this to the end, you don't have to, but I'm going to do that. That's 4 times 4, that's 2 times 2, okay, and then this is 2 times 5. So if you did your factor tree correctly, it looks like you have 5 2's, and you have 1 5. That's what you have. So if you want to do the problem this way, then your next step you could go like this. Okay, you'd have 2 to the 5th times 5 to the 1st. Is anything going to happen to the 5 to the 1st? No, can't come out. How about the 2 to the 5th? You break it up into what? 2 to the 4th and 2. Like that. That's how you've been kind of working on your square roots. So you can have I times 2 to the 4th times 2 to the 1st times 5 to the 1st. If you want to do the problem this way, you're more than welcome to do it this way. I'm going to show you the fast way in a minute. Okay, what's the square root of anything to the 4th? Something to the 2nd, right? Okay, so that's going to be 2 to the 2nd. That comes out of the radical. What's left is 2 times 5, or 10. So your answer to the problem, now you can go ahead and do 2 to the 2nd, would be 4i times the square root of 10. That's it. Now, I wouldn't do the problem that way. I show you the factor tree way because that's probably the best way to get students started on learning this. Here's the way I'm going to do this, like this. Okay? I know that 160 is 16 times 10. Okay? What's the square root of 16? 4. 4 radical 10. You can do it that way. If you see a number that goes into 160 evenly that has a square root, that's a perfect square, you can do it that way and save time. And when you get in higher level math, you will do that more and more as you go. But I like the factor tree way because it teaches an important concept. Okay, has everybody got that? Okay. Now, before we go on, I want to show you this one little thing here, and I do want you to write this down. When you get into checking this, I want to show you real quick how to check your answer on this. Not that hard, but this is where you ultimately start understanding this stuff. So, if you want to check the answer to a square root, you always take your answer and multiply it by itself. I'm going to prove to you that when I multiply this out, I'm going to get negative 160. I'm going to prove that to you. Okay? So when we do this, 4i times 4i is 16i to the 2nd. Okay? If I do the square root of 10 times the square root of 10, I get a square root of 100. Okay? what did I say I squared was? And this is going to be big in this section, so I'm going to write it big. It's -1. Okay? So actually what you would get is 16 times -1. The square root of 100 is 10. You multiply that out, you get -160. That's why it's right. If you do a square root, you can multiply your answer by itself twice and see. All right? Yes? If it's an what? Say it again. Yes. If anytime that you see an I squared, that really becomes -1. I squared's -1. I to the third and higher is different.
So isn't I equal to -1?
Yeah, it goes like this. I is equal to the square root of -1. I squared is equal to -1. And then the rest of the powers are built from that, okay, which we'll probably look at that a little bit next week. Okay, let's look at the next problem, okay? So first of all, with this one, that negative is still there, so you tag it on, and then you're going to break this up into the square root of -1 times the square root of 288, like that. So that's going to be -I, of course that's I, times square root of 288. Okay, now you could do a factor tree and do that, okay, if you want to, or you could do this. This is what I would recommend a student do. Just do a factor tree. Start by doing a factor tree. If I divide it by 2, I get 144. Do you know what the square root of 144 is? 12. So don't go any further. If your factor tree finds for you a perfect square, there's no need to go any further. So you can start doing it a little bit more that way if you want to. So that's going to be -I times the square root of 144 times 2. You save time if you start doing it that way. Okay? Otherwise, some of you may have, I don't even know what that would be. I think it would be 2 to the, I don't know. 2 to the 4th? Yeah, okay. And it'll still work that way. All right, so what I'm going to do is this. The square root of 144 is 12. Then you got a leftover radical 2. So if you did the factor tree all the way to the end, you still should get the same thing. So it's -12I times square root of 2. Okay, that's the idea. Okay, does that look okay? So if you've got that simplifying radicals down, then you won't have much trouble doing this. If you don't, you've got to work on that more. Okay, so the last thing I'm going to do today is kind of do some multiplication and division with imaginary numbers, okay? Pay attention to this carefully because there's a common mistake students make. There's kind of a definition of how we do this. So this is wrong, okay? If you were doing negative square root of 2 times square root of -3, those are both imaginary numbers. So it's wrong to just go through and put them under the same radical like that. You can't do that with imaginary numbers. You're not allowed to do that, okay? That's all I can say is you're not allowed to do that because the math works. At this level of class, that's about all I can say. So that's wrong. Don't do it that way. Do it this way. Okay, so what you're going to do on this is if you have the square root of -2, you're going to write that as I times the square root of 2. Take that I out, okay? If you have the square root of -3, you're going to write that as I times the square root of 3 like that. You have to start that way. You cannot do it that other way, so be sure that you pay attention to that. Now, when we do this, what's I times I? It's I to the second. Now, these are real numbers. See, those are square roots of positive, so you are allowed on real numbers to put those together on their same radical. That is something you can do. You can't do that with negatives. Okay, so that's going to be I squared times square root of 6. Okay, all right. Now, the thing is, as we do these problems, I'll write this real big on the board. I squared is -1. You're going to get that in your mind. Anytime I squared pops up, that's what it's equal to. So what we would do next here is replace that with -1, so we'd have that. So that answer would actually just be negative square root of 6. Now that's real weird to students. It's weird to me too when I first learned this. What this is saying is if you take two imaginary numbers and multiply them together, you get a negative. Okay, that's the way it works. Okay, you don't have to memorize that. The math will lead you to that conclusion if you do it correctly. Okay, let's work some problems out on this and kind of get this out of the way here. Okay, is it right on this problem to start that way? Yes or no? No, I said that you can't, if you have two imaginary numbers, you can't just put them under the same radical. Not allowed. Students do that a lot because they're not paying attention. Okay, so what do you do with the square root of -5? You write it as I times square root of 5. It's an imaginary number, so you just write it that way. There's nothing you can do with square root of 5. Then write the other one as I times square root of 3. Nothing you can do with square root of 3. Okay, what's I times I? I to the second. What's I to the second? -1. Okay. Now you are allowed to put the 5 times 3 together and get 15 because they're positive numbers. So that means the answer to this problem is just -1 times root 15. So it's just a negative answer. So that's your answer to your problem right there. Okay, if you follow the procedure, you won't have any trouble doing this. Okay. Okay, we're going to do the next one pretty much the same way. So this one is I times square root of 10. And then this one is I times square root of 4. Okay? So, now you have two choices. Now you've got to learn when you're a math student, a good mathematician is going to look for things. Okay? You could go through and get square root of 40, right? But how about square root of 4? Do you already know it? Well, just do it. Don't waste your time to get in the square root of 40. Go ahead and do it. You're going to, if you got the 40, you'd have to simplify it anyway. So what you're going to have is I times I is I to the second. I'm going to have square root of 10, and then I'm going to have 2. That just becomes 2 like that. So what you're going to have, the square root of 10, there's nothing you can do with it because the factor tree just has 1 of something, 1 of each number. So you would write this like this. You would put the 2, and when you have an I squared, that just makes that negative because it's -1. You can do that in your head if you want to. Then you would be left over with a square root of 10, so that's the answer to the problem. Okay, you guys see what I did? Start that way. Square root of 4 was 2. That's -1. 2 times -1 is -2. That's how that goes. Okay? That's the idea. Okay, now let's take a look at this next one. Okay? What kind of number is the square root of 49? Is that imaginary or is it real? It's real. So what's the square root of 49? 7. What kind of number is the square root of -1? It's an I. It's imaginary. In fact, it's I, isn't it? Okay, so there's your answer right there, 7I. There's nothing else to do. Okay? All right? Just trying to get you to think and recognize primarily. Okay? Next problem. What kind of number is square root of 2? Real or imaginary? Real. Leave it alone. Okay, how about square root of -27? That's imaginary. So you want to write that as I times square root of 27. Okay, like that. Now, what you can do is you can put these radicals together. So that 2 and 27, since they're positive numbers, can go together like that. Okay? Now, I'm going to go ahead and do a factor tree, okay, just on the 27. We already got a 2. That's prime. So if I have 27, that's 9 times 3. Like I told you a little while ago, if your factor tree finds a perfect square, don't go any further. If you start doing that, you'll start saving yourself a little time. So what I'm going to do here is I'm going to have I times square root of 2, and I'm just going to break that 27 up into 9 times 3. Okay? If you went further with the factor tree, all you would have is you would just have 3 to the second there. That still works the same way you're familiar with. So what comes out of the radical here?
3 squared.
Right, exactly. The square root of 9 is 3. So when you do the square root of 9, that's going to be a 3 out there, right? So what we do is you just do this. That comes out along with the I, so that's going to be 3I. And then what's left under the radical is 2 times 3, so that's 6. So that's your answer to your problem. Okay? All right, so we'll go ahead and just stop there for today.